Hi everyone. This is our project SmartGrowth, an intelligent environmental control and alert mechanism system using STM32 and FreeRTOS. So we have used this STM32 Cube IDE where we have done the pinout and configuration according to the hardware setup that we have made. Now let's look at the hardware connections. Here we have the STM32 F series 446RE and it is connected to various sensors, that is DHT11 sensor which monitors the temperature and humidity, and we have an LDR sensor which detects the light intensity, and we have the soil moisture sensor which detects the soil moisture of the soil bed. And then we have ESP8266 Wi-Fi module which monitors the real-time data of the sensors, and it transmits the data to the ThinkSpeak IoT platform in order to monitor the sensor values, and based on the threshold values that we have set up in the ThinkSpeak IoT platform, the notification alert will be sent to the user using the applets that we have set up in the IFTTT application. Here, the working of each sensor is prioritized with the help of FreeRTOS based on the criticality of each sensor for the soil growth. Now let's look at the working of each code. Now we are connecting the STM32 to the Cube IDE. And now we are debugging the code. Now we resume the code, and here we can see that the sensor values are being updated according to the prioritization that we have given. So initially we see the temperature and humidity values, and then the soil and LDR values are updating. And now with the help of ESP8266, the data is being transmitted, and here we have the ThinkSpeak IoT platform where the real-time data is being updated every 15 seconds in this IoT platform. Here we can see that the soil moisture sensor readings are in the range of 2500, which means that the soil is moist. Here we can see that the soil moisture sensor is in the soil and the soil is moist. So the readings are 2000 in the range of 2500, and that values are being read in the graphical representation in ThinkSpeak IoT platform. Now if I consider that the soil is not moist and the soil is dry, so in that case when the soil sensor is in the dry soil, it reads the values around 4000, which means whenever it is above 3000 that the soil is not moist, and the data of that is also being updated in the ThinkSpeak platform. And as we have set up 4 different applets to enable the user notification. Now we can see that the user is getting the notification from the IFTTT application that the soil value is now exceeded and it is less moist and it's time to water the plant. Now let's look at the working of the LDR sensor. During the daylight, we have the values of it in the range of 1000, and now we are creating a virtual environment to reduce the intensity of the light. So now that I've given this night environment, we can see that the values are going below 900, which clearly shows the change in the LDR values, and the values are updating in the ThinkSpeak IoT platform. And similarly, now the user will be getting a notification mentioning the lower LDR values, saying that the lesser LDR value is detected and your plant needs some rays, and don't leave it in the shade for too long. Lastly, let's look at the working of the DHT sensor. Here we can see that the ideal temperature and humidity values are seen where the temperature is 21 degrees Celsius and humidity is around 70 percentage. And the values are also being updated in the ThingSpeak platform every 15 seconds. Now, in order to create a virtual environment to increase the temperature, we are now placing the DHT11 sensor for a heat to increase the temperature. So now with the increase in temperature, we can see that the temperature is 55 degrees Celsius and the humidity has gone below 50 percentage, and the values are being updated in the ThingSpeak platform, and accordingly the user is also getting the notification saying that the temperature is high and also the humidity is very less, that the plant is very dry and it's time to water the plant.